going to move into section 1.3, which is on page 16 in your packet, and we're going to start talking about graphing functions from their formula. There's one particular function we're going to look at that uses absolute value bars, and then we're going to see how changing the formula changes the shape of the graph and see if we can create some quick shortcuts to be able to let us sketch some graphs very quickly. We're going to take a look at, first of all, graphing the function f of x equals the absolute value of x. First of all, f of x equals absolute value of x. F of x has the same meaning as y. So this is like y equals the absolute value of x. No big deal. We're going to use this notation interchangeably throughout the year. We're going to start graphing this thing the way that you pretty much always started graphing things in Algebra 1. If you had no idea what it looked like, you made a table of values. And that's what I'm going to do. I'm going to take these x values, and I'm going to plug them into my absolute value function. Which means if you plug in x equals -3, you get the absolute value of -3. Well, what do you remember about the absolute value? What is the absolute value of -3? The absolute value tells us how far that number is from 0 on the x-axis. But the kind of shortcut way we can think about it for now is it takes numbers and makes them positive. So make -3 positive, and you're going to get 3. Absolute value of -2 is going to make that positive, and it's going to give us 2. Absolute value of -1 is 1. Absolute value of 0 is 0. What do we want to do the absolute value of a positive number? What's the absolute value of +1? Absolute value, again, remember, it means distance from 0 on the x-axis, or take a number, make it positive. If it is already positive, the answer is positive. Absolute value of 2 is 2. Absolute value of 3 is 3. I'd like you to take a moment and plot those 7 points on your grid over here, -3, 3, -2, 2, and so on. Plot them, and we'll do more in a moment. -3, 3, -2, 2, -1, 0, 0, 1, 1, 2, 2, 3, 3. Now, the absolute value of x is actually a continuous function. Right now it looks like a discrete function with those separate points there. I plugged in nice numbers for x, but really you can plug in any possible number for x. You can plug in 1.5 or -2.3 or really any number. Because of that, I'm going to go, and using a ruler, the ruler that I gave you in class maybe, I'm going to go connect the dots and make this thing continuous. I'm going to get something like that, and I'm going to get something like this. And this is the graph of y equals the absolute value of x. What we now need to see, though, take a moment actually, turn the page to page 17. We're going to look at graphing things that are a little more complicated, like the absolute value of x minus 3, absolute value of x minus 4, absolute value of x minus 2 plus 4. And it is going to be an absolute pain to have to make tables of values every single time to graph these. There are some shortcut ways to figure out what exactly changing these formulas, what this -3 does, what this -4 does, what the -2 and the +4 does to the graph, and then we can use those shortcuts to do our graphing very quickly. Before we go on, you're going to take a moment and take a look at an activity through the website desmos.com. It's posted in Google Classroom, but I'll also make Edpuzzle link you to the activity that you're going to take a look at. And we're going to see if we can figure out what the rules are for how to change the graph based on the numbers. Take a few moments, take a look at that, and then we're going to come back and summarize what you saw. Okay, so hopefully in that Desmos activity, you saw that if we add some number after our function, it's going to move the graph up that many units. If we add some function plus a number, we will go up k units. For example, if I give you y equals the absolute value of x plus 2, your graph, that absolute value v, is going to move up 2 spaces. If we subtract a number outside our function, it's going to move our graph down k units. So if I give you y equals the absolute value of x minus 2, it'll take our graph and go down 2 spaces. If we subtract something inside our function, like if I give you y equals the absolute value of x minus 2, subtracting something inside will move our graph to the right, in this case 2 spaces. In general, I can say it will move it right h spaces. Finally, if I add something inside the absolute value bars, and after this I promise I'll make the videos pause so you can get caught up on all these notes. If I add something inside the bars, like say x plus 2 inside my absolute value bars, it will move your graph left 2 spaces. So in general, if we're adding h inside our function, we will go left h. I don't know why I changed spaces to units. Let me make this units over here as well. Take a moment, get that chart copied down. So, what we now need to take a look at is how we can use these rules to do some graphs very quickly. And you're going to want to get your colored pencils. So if you don't have your colored pencils with you, take a moment, go get those. I'll make the video pause. And we're going to go on to page 17 now. What I'd like to do in letter A is first, probably in regular pencil or in a particular color, is I just want to graph y equals the absolute value of x. That graph that we made the table of values for on the previous page. Remember the one that had points -3, 3, -2, 2, -1, 1, 0, 0, 1, 1, 2, 2, 3, 3. We're actually going to call this graph our parent function. And we're going to see how we make changes to our parent function to get our particular transformation. But right now, I just want to graph y equals the absolute value of x. 0, 0, 1, 1, 2, 2, 3, 3, -1, 1, -2, 2, -3, 3. I'm going to connect the dots. And that's certainly not what the problem asked me to do, but it's going to help me do the problem. Actually, you know what? Before we move on, how about you take a moment and get that exact same graph, y equals the absolute value of x, with those same 7 points on every single grid on page 17. I'm going to work on this, and then I'll make the video pause so you can get all those points on there. But please start working on this right now. 0, 0, 1, 1, 2, 2, 3, 3, -1, 1, -2, 2, -3, 3. So again, you go get those graphs on all 6 grids. I'll make the video pause. Okay. Now we're going to need a different color. In this first problem, we have y equals the absolute value of x minus 3. And our rules from the previous page said if we subtract a number outside our function, outside our absolute value bars, it's going to move our graph down that number of spaces. In this case, I want to move my graph, y equals the absolute value of x, down 3 spaces. Well, all I'm going to do, first of all, I'm going to kind of color code my work a little bit. I drew my parent function in dark blue, and I just labeled y equals the absolute value of x in dark blue, because that is what I started with. And now I want to apply that minus 3 to it. I want to go and move each of my points down 3 spaces. So I'm going to go 1, 2, 3. I'm going to go 1, 2, 3. I'm going to go 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. I'm going to connect those dots. And we should have the same basic shape, but our graph was now moved down 3 spaces. That's all we're doing. As far as the whole drawing the parent function on there, this is going to be very helpful as the graphs get more complicated. This is actually a little bit like those equations that I talked with you about, why we're showing all of our work, because when the graphs get harder, if we have this process down, the really hard graphs are not going to be an issue at all. And we're going to kind of use these same ideas all year long. Anytime we see minus 3 after some function, absolute value of x, or something more involved, it will just always take our graph and move it down 3 spaces. Letter B, can you tell me what that plus 4 is going to do to the graph? I think that should move all your points up 4 spaces. You take a moment, go do that. So again, I'm going to color code things. I'm going to say y equals the absolute value of x plus 4. My plus 4 is moving all my points up 4 spaces. 1, 2, 3, 4. 1, 2, 3, 4. You know, you don't have to actually hear me count out loud. I'll count in my head. Connect those. And I get something like this. And that's what your final graph's going to look like. I think it is helpful to have the 2 graphs on the same grid, but make sure I know which one is which. That's why I'm doing this color coding over here. That's my way of telling you what each graph is. If you take a quiz on this and I just see a whole bunch of graphs all in regular pencil, I'm not going to know which one's the final graph, and I'm not going to be able to give you full credit for that. Let's take a look at letter C. This time, I'm subtracting 4, but I'm subtracting 4 inside the function. Take a look back at page 16 and tell me what this minus 4 inside the bars is going to do to the graph. I think since it's inside the bars, we're going to go right 4 spaces. So do that. Take all your points, move right 4. Y equals the absolute value of x minus 4. Again, I'm going to color code my work. Go move your graph right 4 spaces. And it should look like that. Tell me what's going to happen in letter D. How will our regular absolute value of x get transformed? I think that plus 2 inside the bars, when we add something inside the bars, it moves our graph to the left. So in this case, left 2 spaces. Please take a moment. Go move that graph left 2 spaces. And I think it should look like that. Do make sure you are plotting specific points. I do need to see those individual points. Make sure you're sticking arrows at the ends, all that good stuff. Okay, 2 more graphs for this video. Letter E. Y equals the absolute value of x minus 2 plus 4. There are 2 things going on here. What's the minus 2 going to mean? I think if you're subtracting 2 inside the bars, that means we're going right 2. What's the plus 4 going to mean? I think if we're adding 4 outside our function, it's going to move our graph up 4 spaces. When these get a little bit more involved, we're going to want to do just one of these things at a time. We would go right 2, do that graph, and then in another color go up 4. But I think because here we're just moving right and up, I think we can do it all in one step. I'm going to go do y equals the absolute value of x minus 2 plus 4. I'm going to take this point over here, I'm going to go right 2, and I'm going to go up 1, 2, 3, 4. I'm going to take this point, and I'm going to go right 2, 1, 2, up 1, 2, 3, 4. I'm going to take this one, right 1, 2, up 1, 2, 3, 4. Right 1, 2, up 1, 2, 3, 4. Keep doing that. Right 2, up 1, 2, 3, 4. Right 2, up 1, 2, 3, 4. Right 2, up 1, 2, 3, 4. Connect the dots. Take a moment, get caught up on that one. Can you please tell me how we're going to move our parent function in letter F? Well, the plus 1 inside is going to move it to the right 1. The minus 2 outside is going to move it down 2. Go do it. I'm getting something that looks like that. And that's what your graph should look like. One last thing for this video. I'm giving you some graphs, and we want to write the formula for this graph. Well, over here, so they're all translations of y equals the absolute value of x. Basically, I want to create a formula like what we had on the previous page. My answer in letter A is going to be y equals the absolute value of x. Now, do I need anything inside the bars with that x? And if so, what am I going to need? Well, I think this graph was shifted 4 to the right. How do I move 4 to the right? I'm going to say minus 4. Outside the function, we add or subtract if this thing was moved up or down. However, I don't think we moved this graph up or down at all. I think it was just right 4. So to show right 4, I'm just going to say y equals absolute value of x minus 4. I could have also, by the way, written it as f of x equals the absolute value of x minus 4. But please make sure they are functions. Make sure they're either y equals or f of x equals. See what you can do in letter B. And when you're done, send that answer in to Edpuzzle. You know what, before I do this, let's see. I'm moving right 2. And looks like up 5. So to show the right 2, I'm going to do absolute value of x minus 2. To show up 5, I'll just put a plus 5 at the end. So this is the basic idea behind the graphs. It gets a little bit more involved when there's a number out front, as you saw in that Desmos activity, but we'll save that for the next video.